All right, good morning, everyone. So this week, we're kind of getting into the final stretches. We don't have many weeks left, so let's just jump into it. Last week I had a lot of questions, and that's not how you spell it, on how do I know what 5 pi over 6 is, and how evaluating that, like the 6 trig functions of that. So I thought about it, and I'm going to give you guys this like little chart, I guess, that I probably should have made last time, but just as with your reference angles, okay? So remember, in quadrant 1, you have your reference angles. You have 30 degrees, 45 degrees, 60 degrees. Those are like the big ones. They'll deal with the triangles, right? So we're going to do quadrant 2. We're also going to do, actually, let's space these out a little bit more, because we're going to want to put radians underneath it as well. Quadrant 2, quadrant 3, and quadrant 4. All right, so this is just like a quick reference thing. So in the second quadrant, these are your reference angles here. This would be 150 degrees. In your third quadrant, it's 210 degrees. And in your fourth, it's 330 degrees. And if you go back to last week's second video, we talked about reference angles and how to find those. I'm just giving them to you now because, for time's sake, really. 45, you in the second quadrant's 135 degrees. In the third quadrant, it's 225. In the fourth, it's 315. One thing I want to point out to you guys, every single one of these ends with a 5, right? So that should be a clue when you're trying to evaluate them to figure out what the reference angle is. Not always going to be that way, excuse me, but definitely something to look at. 60 degrees, second quadrant angle is 120, third quadrant's 240, and the fourth quadrant is 300 degrees. So this is all in degrees, but in radians, 30 degrees is pi over 6. 45 degrees is pi over 4. And 60 degrees is pi over 3. So we're going to put all the radian measures as well. So we're going to put 150 is 5 pi over 6. 210 is 7 pi over 6. 330 is 11 pi over 6. And again, if you don't know how I did those, go back to the degrees and radians part. I think that was 2 weeks ago or something like that, where you multiplied by pi over 180 and you reduce that fraction. But one thing to point out, look at the denominators. Everything's over 6. And you see that pi over 6 is hidden in there. So whenever you see something like that over 6, you know your reference angle is going to be 30 degrees. That way we would know we would use a 30, 60, 90 right triangle when we're trying to figure it out. Okay, 45 degrees are pi over 4. Second quadrant's 3 pi over 4. Then we have 5 pi over 4, and then 7 pi over 4. Okay, so all of those. Again, everything's over 4. There's a pi over 4 in every single one. So we know we would use the 45, 45, 90. That's 1, 1, and root 2. Okay, 60 degrees. Well, if we have pi over 3, we're going to have 2 pi over 3. Then we're going to have 4 pi over 3. And then 5 pi over 3. And that one again, everything, you see that pi over 3 hidden in there, you know your reference angle is pi over 3. And pi over 3 is 60 degrees, so you would use your 30, 60, 90 right triangle. So by knowing those, hopefully that would kind of help you evaluate some of them. So we're going to use those to try to figure out how we would do this without a calculator, and see if it would be easier knowing this now. Okay, the only other angles you would ever have are the ones on the circle there. okay, which would be 90 or pi over 2, and this is 180 degrees or pi, and then 3 pi over 2 or 270 degrees, and 2 pi, and this is 360 degrees. Okay, and you also have 0 degrees and 0 radian. But those are the only ones you would be doing. Those had the points, if you forgot. This is 1, 0, 0, 1, negative 1, 0, and 0, negative 1. All right. So really, that's all you're going to need to know is that circle and those two triangles. So let's see if we can use those to evaluate some trig functions. So let's just go with 240 degrees. I just want to know the sine, cosine, because once we know these three, we can figure out the other three. Rather simple. So I'm not even going to bother writing those down. But 240 degrees. So really what you want to do is, well, think about it. Well, you can either look at the chart that we just kind of bootlegged. 240 is in the quadrant 3. All right. And then to find the reference angle in quadrant 3, I'm going to do 240 minus 180. And that's going to give me 60 degrees. So that is my reference angle. So that means I'm going to use a 30, 60, 90. And I base everything off 60 degrees. So sine is opposite over hypotenuse, so root 3 over 2. Cosine is adjacent over hypotenuse, so 1 over 2. And tangent's opposite over adjacent, so root 3 over 1. But since we're in the third quadrant, remember last week we also did all seniors take calculus or take courses, whatever. So only tangent is going to be positive. So that means sine is negative, cosine's negative. Then you'd be done. Let's do another one. Let's do 330. All right. So we need your sine of 330, the cosine of 330, the cotangent of 330. So 330 degrees is in quadrant 4. It's really almost 360. And our reference angle there in quadrant 4, we do 360 minus our angle, so 330. So we get 30 degrees, so that's our reference angle. 30, 60, 90, 1, 2, root 3. All right. Now we're just doing some SOHCAHTOA. Opposite over hypotenuse, so 1/2. Adjacent over hypotenuse, root 3 over 2. Opposite, oops, that's not a negative, that's me pointing. Opposite, so 1 over root 3. Quadrant 4. All students take classes. Only cosine's positive, so tangent and sine are both negative. You'd be done. All right. Do do ba beep beep do 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 do. All right. Let's do, I don't know, what do we want to do? Let's do 3 pi over 4. So we're going to do the sine of 3 pi over 4, the cosine of 3 pi over 4, the tangent 3 pi over 4. Oop. All right, it's over 4. You don't even have to worry about subtracting anything. If it's over 4, you know your reference angle is pi over 4. The only other thing you need to kind of point out for yourself is which quadrant this is in. And this is in quadrant 2. And how do I know quadrant 2? Well, if this is 0, this is a half of a pi. This is a whole pi. This is 1.5 pi and 2 pi. So it knows I'm greater than 1/2, but less than 1. So I'm over in the second quadrant right here. All right. So based on that, pi over 4 is a 45, 45, 90. So 1, 1, root 2. So opposite over hypotenuse. Adjacent over hypotenuse. Opposite over adjacent. All right. Use your signs from the quadrants. We're in quadrant 2. I have my thing here. All students take classes. Just signs positive. So that means cosine's negative, tangent's negative. Those would be your answer. Okay. Let's do another one. I'm just going to keep drilling it, but we're going to do this one in radians again. Let's do 5 pi over 6. So we knew the sine of 5 pi over 6, the cosine of 5 pi over 6, the tangent 5 pi over 6. Okay, pi over 6. Like I told you, there it is. That's a reference angle. If you ever have anything with that hidden pi over 6, there it is. Bam. So that's your reference angle, which is 30 degrees. So we use our 30, 60, 90 right triangle. And then we base everything off of 30 degrees. So we do opposite over adjacent, 1/2. Ooh, which quadrant we in? Sorry. This is in quadrant 2. We kind of need that for a minute. Well, later on. For our signs. So back to the cosine. Adjacent over hypotenuse. Root 3 over 2. Tangent, opposite over adjacent. 1 over root 3. And if we're in the second quadrant, all students take calc. Just S is positive, so just signs. That means the other two are negative. And again, once you know these 3, you are done. Because the other 3, you just flip every single fraction. That's all you would do. It's really not that bad. Okay, so most of these things you'd be expected to do without a calculator if we were in school. Obviously, you can use a calculator now and such, but you want to try to practice these as if you're going to have calc next year and not being allowed to use a calculator to evaluate them. All right, so what happens if we have something like 7 pi, right? I want to know the sine of 7 pi, the cosine of 7 pi, and the tangent of 7 pi. That's a 7 pi, it's well above 2 pi, right? There's a few rotations there. So if we were to sketch this angle, it'd be, well, there's 2 pi, 4 pi, 6 pi, 7 pi is right there. So that means my reference angle is just a good old-fashioned pi. All right. So what that means is I have to use the circle now. Remember we gave you guys this when we were talking about the triangles. So this is really -1, 0 at pi. So we have all these points and whatnot there. But all you really need is -1 and 0. And if you forgot how to use those, remember, if you have that, the sine of your angle is your y value. The cosine of your angle is your x value. This only goes for the circle. And the tangent of your angle is y over x. So, based on the points, or the point 0, -1, 0, the sine is going to be 0. The cosine is -1. The tangent is 0 over -1. Or just 0. You'd be done. This also goes if you were to go in negative direction. Okay, this was positive 7 pi, so we had to do a little math, or not really math, but sketching to figure out what my reference angle is. So let's do -7 pi over 6. I already know what my reference angle is. I see it hidden. It's hanging out right there. All right, but you need to figure out what quadrant that's in. All right, negative direction, so that means I'm going to start going that way. But this is now going to be -pi over 2. This is -pi, -3 pi over 2, and -2 pi. And negative 7 pi over 6 is greater than negative 1. Well, I guess lower than negative 1? Whatever. But it's somewhere in this quadrant here. So now we're technically in quadrant 2 with a reference angle of pi over 6, or 30 degrees. So we're going to use our triangle. 1, 2 in root 3. And then we'll do 30, 60, 90. So let's do the sine of negative 7 pi over 6, the cosine, negative 7 pi over 6, the tangent, negative 7 pi over 6. Okay, so we're doing all right. And then we just follow SOHCAHTOA. Opposite over hypotenuse, so 1/2. Adjacent over hypotenuse, root 3 over 2. Then opposite over adjacent, 1 over root 3. Okay. And then follow the quadrant signs. And in quadrant 2, all seniors, just S. So tangent and cosine are both negative. This would be our answers. Ta-da! All right. So I think we're doing okay. If I am going too fast, you guys pause it, rewind it, rewatch it. If you have questions, come to the hangout. I've been missing everybody. I've only seen like maybe 3 kids the past 2 weeks. You know. But hey, not gonna chirp any of you. If you just get it, you get it, you know. By the way, who puts question marks on homework when you can come to a hangout and ask questions about those questions? Questionception. That's right. Okay, you're going to see some weird instructions in this homework. So it's going to say solve for theta, and theta is going to be between 0 and 360. Or it could say 0 and 2 pi, like that. What this means is that you have to give all possible answers. So all possible solutions is kind of key. So let's say we have the sine of theta is root 3 over 2. I had some questions about this last week that I wanted to kind of review as well. So let's talk about it. So if it's root 3 over 2, we have to figure out which angle, or reference angle, has a sine being root 3 over 2. Well, your options are coming from the triangles or the unit circle. So we have 1, 2, root 3, 30, 60, 90. And then we have 1, 1, root 2. This is 45, 45, 90. And then we have our circle. So those are like the only options we really can play with this. Because again, this would be something without a calculator that you'd be expected to do. All right. So we have 0, I guess 90, 180, 270. Let's not worry about pi. All right, but we can do those too. All right. So those are the only things we kind of have. Remember, the point here is 1, 0, 0, 1, negative 1, 0, 0, negative 1. All right. Well, there's only one spot you're going to see a root 3. And the root 3 is always in the 30, 60, 90. So now what you have to do is look at either 30 degrees or 60 degrees and find out which one has the sine opposite over hypotenuse, being root 3 over 2, and the opposite over hypotenuse, this is 60 degrees as my reference angle. But I want to know all the possible values. Well, that means 60 degrees is one of my answers, but it's saying what other angle has the sine being root 3 over 2? This you can't type in your calculator. It won't give you both answers. It's actually only going to give you 60 degrees. But the thing you have to remember is all students take calculus. Sine, in this case, is positive. So I know I'm going to be in the first and the second quadrant. So 60 degrees is my first quadrant answer. My second quadrant answer is going to be 120 degrees because I took 180 minus 60 from it. So these are my answers. You should have 2 for every single one of these problems. Well, unless it's on the circle. Circle, you only have 1 answer. All right, let's try another one. Sometimes I know the book's going to give you guys the answer with the denominator rationalized because the book is very fancy and likes to rationalize the denominator. So let's do one of those. So sine is negative root 2 over 2. All right, so the sine is negative root 2 over 2. Well, we already know our reference angles because there's only one triangle that has a root 2 in it. And the only one with the root 2, well, the other one has a root 3, so the root 2 is your 45, 45, 90. So I want to say my reference angle is 45 degrees. But sine's negative, so I have to figure out which quadrant am I in. Well, all seniors take calc. Well, sine's positive in the first and second, so I have to be in my third and fourth quadrant. All right, so if my reference angle is 45, my third quadrant angle is 180 plus 45, so that's 225. Then in my fourth quadrant, that's 360 minus 45, at 350 degrees. Okay. We could do the exact same thing if we were to do cosine. Like the cosine of the angle is negative root 2 over 2. You still know your reference angle is 45 degrees. Ooh. But then you have to distinct the different quadrants because cosine is negative here. So cosine on the quadrants are positive in first and fourth. So I have to look for a second quadrant and third quadrant answer. So my second quadrant answer is I'm going to do 180 minus 45, which is 135. And then 180 plus 45, and then get 225. So those are the two answers for that. Could this be in radians? Of course it could be in radians. But it doesn't really, we don't have to really worry about that. You guys can just use that chart. Let's step it up a notch, huh? Because I think we're doing all right on time. We're about 23 minutes in, something like that. Tangent of Pokeball is going to be negative root 3. So only one triangle has a root 3 in it. So look at the triangle. This is really root 3 over 1. Okay, or negative root 3 over 1. So I'm going to give you time to think about what an angle is because I don't want to have to keep redrawing it. But if it has a root 3, it's a 30, 60, 90. So you're going to have to figure out which angle has the tangent being root 3 over 1. And that, my friends, is 60 degrees. But that's the reference angle. Tangent's negative. So the quadrants we're in the second quadrant and the fourth quadrant. So that means our answers are going to be 180 minus 60, so I get 120. And 360 minus 60, and 300 degrees. So that's not too bad. Not too bad, not too bad. So now what's going to happen if you get like a cosecant or a secant instead of like sine, cosine, or tangent? What I recommend you do is just flip it, you know. You don't have to flip it though. But let's talk about secant. If the secant is like negative 2 root 3 over 3, like that one's kind of gross looking. But again, if you're looking at this answer, only one triangle has root 3 in it. It's a 30, 60, 90. Okay, so we know it's either going to be 30 degrees or 60 degrees. But then you have to do the secant. This is exactly the same thing as negative 2 over root 3. Right, they mean the same thing. They just rationalized the denominator in the book. So now I need to figure out, well, secant is really the flip of the cosine. So I need to do, instead of adjacent over hypotenuse, I have to do hypotenuse over adjacent. So hypotenuse is 2, adjacent is root 3. That must mean my reference angle is 30 degrees. And now I go and use the signs like we have. So all seniors take calc. Well, we're basing everything now off a cosine because the secant is the reciprocal of cosine. So cosine's negative in the second and third quadrant. So my answers, using my reference angle of 30, is 150 degrees. And what is that? 210. And that would be it. All right, so could we do more of these? Yeah. Would it be boring you to death? Probably. Okay. I think the next thing I want to do is just introduce you guys to the graphs of these things. We'll do a lot more detail in the next video on the graphs, but I want to show you what they kind of look like. All right. So if you had the graph y equals sine of x, graphing these on your calculator is like the worst thing ever. I'm not gonna lie to you. Like it is just, it's not convenient in any way. But so you're either going to have a 1 and a negative 1, and then we're gonna have some special points. We have 0, and for some reason math teachers in math books always do things in radians when it comes to graphing. So I'm going to do the corner angles for my unit circle. 0, pi over 2, pi, 3 pi over 2, and 2 pi. All right. The sine of 0 is 0. The sine of pi over 2 is 1. Again, this is all coming from the unit circle. All right. So it's just the y value. So at 0, it's 0. At pi over 2, it's up at 1. At pi, it's 0. At 3 pi over 2, it's negative 1, the y value. See how it's down here. And at 2 pi, we're back at 0. So what you do is you create a sine curve. And this does continue in both directions and so forth, like it does, but what we're sketching here is what we call one period, and we'll get into that more detail in the next video. But again, everything's going to be based on the unit circle. So if we were to do cosine, cosine's the x coordinates instead of the y coordinates, just still on the unit circle. So we're going to top out at 1 and negative 1. So we have 0, pi over 2, pi, 3 pi over 2, 2 pi. So we're still going to deal with this. I'm just going to drag it down just so we can use it. So now we're looking at the x coordinates. So x coordinate at 0 is really positive 1. X coordinate pi over 2 is 0. At pi, it's negative 1. At 3 pi over 2, it's 0. And at 2 pi, it's 1. So then you're going to get basically the same curve. It's just shifted over. Because again, it continues. kind of crazy. But if you look at it, and if I was to take this graph and to shift it that way a little, I'd have the same thing. So sine and cosine are really closely related. That's basically what I'm trying to get at. So the next video we'll be talking about this in a little bit more detail, and then we'll be done. My kid's talking to me through the heater. That's the best thing ever. All right, we'll see you.